In 2020, a NASA spacecraft took a soil sample from an asteroid. That's an amazingly accurate task considering both the spacecraft and the asteroid were travelling at incredible speeds. In this video, we'll learn a rule to calculate the distance between two coordinates, a bit like how NASA calculated the distance between their spacecraft and the asteroid, although we'll do a simpler version. It's really like using Pythagoras' rule on a Cartesian plane. First, let's quickly revise Pythagoras' rule. Here's a right-angled triangle where side A equals 3 and side B equals 4. We will use Pythagoras' rule to calculate the length of the longest side of this triangle that is called the hypotenuse or side C. Here's the rule. C squared equals A squared plus B squared. A equals 3 and B equals 4. So A squared equals 3 times 3, B squared equals 4 times 4. 3 times 3 is 9, 4 times 4 is 16, so 9 plus 16 is 25. So C squared equals 25. But we want to find the length of C, not C squared, so there's one more step. We square root 25 to find C. So C equals 5. The length of the longest side of the triangle, that's the hypotenuse, is 5. Now let's do that on a Cartesian plane. Here are 2 points, 1, 2 and 4, 6. We will find the distance between these 2 points. First, draw the right-angled triangle. Notice that the distance going straight across between these 2 points in the x direction is 3. And the distance going straight up between these 2 points in the y direction is 4. So using Pythagoras' rule, we square the side going across, that's the 3, and we square the side going up, that's the 4. Then these are added. Last, we square root to get the hypotenuse of 5. The distance between these 2 points is 5. We'll do this same question with a rule that really is Pythagoras' rule that is especially adapted for points on a Cartesian plane. But before we use this rule, we just need to understand what some symbols mean. Let's get back to the 2 points. Here is the first point that we will call x1, y1. And here is the second point that we'll call x2, y2. And here is the rule. The distance between the 2 points is the square root of x2 minus x1 in parentheses and then squared, plus y2 minus y1 in parentheses and then squared. Now what does it mean? Look closely. Remember that side A in Pythagoras' rule was the distance going straight across in the x direction. Well, that's the same as the difference between x2 and x1, like this. And remember that side B in Pythagoras' rule was the distance going straight up in the y direction. Well, that's the same as the difference between y2 and y1, like this. Now we square these and then add them. Lastly, we find the square root to get the hypotenuse, that is really the distance between these points. It's really Pythagoras' rule, but with points on a Cartesian plane. Okay, let's use this new rule using the points 1, 2 and 4, 6. So x1 is 1, y1 is 2, x2 is 4 and y2 is 6. Let's substitute these into the rule. x1 is 1, y1 is 2, x2 is 4 and y2 is 6. Now subtract the x's to get 3 going across. Subtract the y's to get 4 going up. Square these. Now add. Lastly, square root. The distance between the points 1, 2 and 4, 6 is 5. This same rule can also work out the lengths of plastic filament used by a 3D printer, just like this one on the International Space Station. Let's say the distance of a filament must go from -2, -5 to 3, 7. How long is that? We'll use the old Pythagoras rule, and then we'll use the new rule that works on a Cartesian plane. The distance going across from -2 to 3 is 5. The distance going up from -5 to 7 is 12. Here's Pythagoras' rule. C squared equals A squared plus B squared. A equals 5 and B equals 12. So A squared equals 5 times 5. B squared equals 12 times 12. 5 times 5 is 25. 12 times 12 is 144. Let's add them. 25 plus 144 is 169. So C squared equals 169. But we want to find the length of C, not C squared, so there's one more step. We square root 169 to find C. C is 13. The hypotenuse is 13. We'll do this same question with the new rule on the Cartesian plane. The first point x1, y1 is -2, -5. The second point x2, y2 is 3, 7. We substitute that into the rule. x2 is 3, x1 is -2, y2 is 7, y1 is -5. Now we subtract these. 3 minus -2. Be careful. When two negative signs are together like this, they become positive or a plus. So it becomes 3 plus 2, which is 5. 7 minus -5. Again, two negative signs together become plus. So 7 plus 5 is 12. Now square these. 5 squared is 25. 12 squared is 144. Then add these to get 169. Lastly, the square root of 169 is 13. The hypotenuse of C, that is the distance between the 2 points of -2, -5 and 3, 7, is the same distance of 13. Thank you for watching.